The last couple of videos we talked about law of sines as a way to solve for missing sides and missing angles in a triangle. There is another method besides law of sines that, oddly enough, is called law of cosines, and so instead of involving sines, it involves cosines. When do you use each one? Well, it depends on what kind of information you have and what you're trying to find. So law of cosines works when you know two sides in an included angle. That's the case for side angle side. Or when you know all three sides. So that's what law of sines can't do. In other words, law of sines is sine of an angle over the side, sine of an angle over the side. If all you have are three sides, law of sines is not going to work because you need at least one of those angle measures. Law of cosines can work without knowing any of the angle measures. And so that's one case where law of cosines is going to work, that law of sines is not going to work. So it says for any triangle ABC, there's my equation. I knew it was coming. C squared equals A squared plus B squared minus 2AB cosine C. Oh my goodness, that's a long equation. Yes, we have to memorize it. You notice it looks suspiciously like the Pythagorean theorem, except there's a minus 2AB cosine C at the end. So what is angle C? Angle C is the one angle we have in the triangle. The side we're solving for is the side opposite that angle. The other two pieces, right, this A and that B, really can go in either order, right? It's just side squared plus side squared minus 2 times side times the cosine of the angle between them. And the rest is just algebra. So it says two sides of a triangle measure 5 inches and 8 inches. So 5 inches, 8 inches. The included angle measures 23 degrees. Find the length of the third side. Well, the length of the third side, notice, is the side opposite that 23-degree angle. So the way I set it up is I'll put my c squared on this side, and then what's all the way on the other side of the equation is the cosine of 23 degrees. So look, the angle is over here. The side is all the way on the opposite of the angle. So the c squared and the cosine of 23 degrees have to be all the way on the opposite sides of each other from the equation. What are the other two numbers? They're 8s and 5s. So 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 23 degrees. And that's the whole thing. So c squared equals, watch your order of operations, 8 squared is 64, 5 squared is 25, 2 times 8 is 16, times 5 is 80, cosine of 23 degrees. So this is the simple case in that I can just throw it all in a calculator. Just again, watch order of operations here. We're going to do a 64 plus 25. That gives me 89. So c squared equals 89 minus 80 times the cosine of 23 degrees. And again, make sure that 80 goes with the cosine of 23, that you're not accidentally doing 89 minus 80 and then multiplying it by the cosine. So 89 minus 80 cosine 23, I get 15.36. But 15.36 is not the third side of the triangle. That's the third side of the triangle squared. Now take the square root of both sides. So I take the square root of 15.36, and I get 3.92 inches, because that's what they were given in. Which should make sense, right? The 23-degree angle is probably the smallest one in the triangle. Well, that means that the short side should be opposite that small angle. So if I had an angle of if I had a side of 15.36 opposite that tiny angle of 23 degrees with the other two sides only being 5 and 8, something went wrong, and yeah, sure enough, you forgot to take the square root. All right, this is the case of having all three sides. So a triangle has sides of length 5, 6, and 7. Find the measure of the angles. Well, let's draw ourselves a picture. We can label the angles anything we want. Be creative and call it ABC. So let's first start with A. Right? Angle A I don't know, but I know the side opposite A is 6. So I'm going to put an A squared over here, and I'm going to put a cosine of angle A over there. What are the other two sides that I don't know, or that I know? It's the 5 and the 7. So 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of A. You notice that I have another side, right? This over here is side A. So when I put the A into the equation, it's got to be squared. So I get 6 squared equals 5 squared plus 7 squared minus 2 times 5 is 10 times 7 is 70 cosine of A. So don't forget to square that 6. That's why I put the A squared first. And then I showed you that A is 6. So I get 6 squared. So 6 squared is 36. 25 plus 49 is 74 minus 70 cosine of A. And all we have to do now is battle order of operations. So we subtract the 74 from both sides. Okay? Because we undo addition with subtraction. So 36 minus 74 gives me negative 38. So I get negative 38 equals negative 70 cosine of A. And now that 70 is multiplied by the cosine of A. So divide both sides by negative 70. 38 divided by 70 gives me 0.5429. So that's the cosine of A. So the inverse cosine of 0.5429 is the measure of angle A. All right, let's find out what that is. So inverse cosine of 0.5429 gives me 57.12. So a measure of angle A, 57.12. Now, let's repeat this process for one other one, because then once we have two of the angles, then we could just subtract from 180 to find the third one. But we're kind of stuck until we get that second one. So, I don't know, let's do B. So B squared equals, and then on the other side I'll put the cosine of B. The side opposite B is 7. So that must mean that 5 and 6 are the two sides that are on either side of angle B, right? They're the two adjacent sides. So 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of B. All right, what is B? B is 7. So I get 7 squared equals 25 plus 36 minus 60 cosine of B, and I work my way back through order of operations, right? So 25 plus 36 is 61. So subtract a 61 from both sides. 49 minus 61 is negative 12. And then on the other side, I get a negative 60 cosine of B. Divide both sides by negative 60. And negative 12 over negative 60 is just a fifth. 0.2 is a decimal. So then the measure of angle B must be the inverse cosine of 0.2. 78.46. So I can fill that in. The measure of angle B, 78.46. And now the measure of angle C is just 180 minus those two numbers. So 180 minus 57.12 minus 78.46. 44.42. And these are all in degrees. Now, quick check. The smallest angle should be opposite the shortest side. So angle C is the smallest angle, is opposite the one with the side of length 5, which is the shortest side. B is opposite the longest side. A is opposite the one in the middle. So this all makes sense. All right. You may end up with a slightly different answer in that second place based on rounding, but otherwise we should all be pretty close. All right, what else are we going to do with this? Rhombus has a side of length 10. One of the angle measures is 50. Find the length of the diagonals. Well, what do you remember about a rhombus? Rhombus has 4 congruent sides. So if they gave me one side, they give me all the sides. So every side of a rhombus is 10. One of the angles measures 50 degrees. So let's put it here. says find the lengths of the diagonals. Well, look at the angle that I've got up at the top, right? It's a triangle with sides 10, 10, and an included angle of 50. So let's call that the first diagonal. D squared goes on one side. Cosine of 50 goes on the other side. What are the two side lengths on either side of that 50-degree angle? It's 10. So 10 squared plus 10 squared minus 2 times 10 times 10 times the cosine of 50. All right, so 10 squared is 100 plus 100 is 200. 2 times 10 is 20. 20 times 10 is 200. And now we have to do a little calculation, so let's grab a calculator and do 200 minus 200 cosine of 50. All right, I get 71.44, but that's not the final answer. That's the side squared. All right, so now take the square root of that. So square root of 71.44 gives me 8.45. And now that makes sense, right? 71 was way too big for the diagonal of a rhombus where the other two sides were 10. But a diagonal of 8.45 makes sense. Now we got to find the other diagonal. Well, how do we find the other diagonal? Let's look at it going this way across. If this angle is 50, and this angle over here is 50, right? 50 plus 50 is 100. All the four angles of a rhombus add up to 360. Well, if two of them add up to 100, that must mean the other two add up to 260. So take half of that, and you'll get this angle here. Which means that my second triangle looks like this. 130-degree angle over here. Red diagonal up at the top. 10, 10. Right, what's the formula? Diagonal squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times the cosine of 130 degrees. Again, 10 squared plus 10 squared is 200, right? 100 plus 100 is 200 minus 200 cosine of 130. But that equals the diagonal squared. So once we get a number, then we'll take the square root of it. So let's try it. Try it on your calculator. I'll try it on mine. Right, 328.56. And now take the square root. 18.12. And there's my other diagonal. And it should make sense that this one is significantly longer than the other one because the angle of 50 degrees is significantly smaller than the angle of 130. So when I make that angle much bigger, I'm going to make the side much bigger. So this is one of these rhombi that are stretched out as opposed to being more square-like. All right, the last thing that's in this section, I've seen it both ways. The textbook calls it Heron's formula. I've also seen it called Hero's formula. Hero's formula helps you to find the area of a non-right triangle when you know all three sides. So again, it's one of these things that is very specific, but yet we know a formula for it. So Heron was a Greek mathematician. He's also our hero when we can't find the area of a non-right triangle. So it involves two sets of variables. One is the side lengths A, B, and C. The other is what we call the semi-perimeter. So the semi-perimeter is just the perimeter divided by 2. Right? So take A plus B plus C and divide it by 2. That's what the S is in this formula. So there's the formula. The formula is the product of the semi-perimeter, then the difference between the semi-perimeter and each of those sides, then you multiply them all together. After you multiply them together, take the square root. So this says find the area of a triangle with sides of 5, 6, and 7. We saw that triangle before. Let's try it now. to find the area. Right? Last time we were finding angle measures. This time we would like to find area. So the semi-perimeter is 5 plus 6 plus 7 over 2. So 5 plus 6 is 11, plus 7 is 18. 18 over 2 is 9. So when we go to find the area, it's the square root of the semi-perimeter, and then the semi-perimeter minus each of the sides. So 9 minus 5, 9 minus 6, 9 minus 7. So 9 minus 5 is 4, 9 minus 6 is 3, 9 minus 7 is 2. So here, now I can actually simplify. Well, I can simplify one of two ways. One is just to multiply everything together. 9 times 4 times 3 times 2 gives me the square root of 216. And then I look for the biggest perfect square factor inside of 216 because I want to simplify it. And so I come up with 36. So this gives me square root of 36, square root of 6, which is 6 square root of 6. That's my area. The other option is to do this, right? The square root of 9 times 4 times 3 times 2 is really the square root of 9 times the square root of 4 times the square root of 3 times 2, which is 6. Well, the square root of 9 is 3. Square root of 4 is 2. Same answer. Right. So I just looked for some perfect squares and pulled them apart. In the other way, you multiply them all together, and then you find the biggest perfect square. Of course, the second way makes the numbers smaller. That's the advantage. The first way, maybe if you don't see those perfect squares right away, you can still find the answer. So just a quick summary of what we did. Law of sines is when you have angle, angle, side, or angle, side, angle. And then two sides in the non-included angle is the ambiguous case. That's where for law of sines, you could get either two triangles, one triangle, or no triangle. Law of cosines is when you have side, angle, side, or law of cosines you have to use when you have all three. Sometimes you can use find missing pieces and missing angles and use one rule or the other. In this case, if all you have are three sides, then you have to use law of cosines because law of sines requires that you have at least one angle measure in order to solve it. And that's it. Now you've seen law of sines and law of cosines.